Okay, so the next question is about chain rule. One of our favorite questions about chain rule problems in the exam is we give you a table of values about values of f, values of f prime, values of f double prime, g prime, all totally irrelevant values. Some of them are relevant. Then we ask you to find the derivative of f composite g at a certain point. Okay? If you take the derivative correctly and then follow the table according to your formula, then you'll get a number. Okay? But in the table there will be 20 numbers. You'll probably need only 2 or 3 of them. Okay? So this this question is a similar one, except that instead of preparing a table, which is hard work, I wrote formulas. So we'll follow the formulas. I don't know if such functions exist or not, but this is an exam, so you just accept it. Okay, so we have 2 functions, f and g. We want to evaluate the derivative of these at certain points. So this is number 5. Okay. F, G, and F composite G are differentiable functions. Okay, so that's what we assume. So F composite G is defined. Okay. The values of these functions at integers are given as follows. Okay, so I just invented something. F of n is equal to 2n plus 1. F prime n is equal to n squared plus 1. F double prime n is n squared minus 1. I don't know if such a function exists. Maybe we can write it. But we are not interested in that. This is just an exercise. G double prime n equals 3n plus 1. And n is an integer. Okay, so this is the sign of integers. Okay. So the question is, using this table, find the values of f composite g at 2. Okay, so this is going to be straightforward. Then take the derivative, since this is calculus, at some point. And why not take the second derivative? Because this is an exercise in chain rule and evaluate it at 4. Okay, so this part is a typical exam question. Okay, but instead of these formulas, here we'll give you a huge table where the values of f and g and derivatives at several points are given, and then you have to chase these numbers and find them. So here we'll chase the numbers with these formulas. Okay, so here this one is straightforward. For these ones, we'll take derivatives correctly. Okay, and then plug in the values starting with these formulas. Okay, so let us write f composite g. F composite g at the point 2. Well, the definition of this is f of g of 2. Okay, so we have to find g of 2. G of 2 is 3. F of 3. F of 3 is 6, 7. Okay, so the first question must be an encouraging problem. Okay, so this one is done. So for the second one, first let us look at f composite g of x. Take the derivative with respect to x, and then plug in x equals 3 and undo it like we did here. Okay, so f composite g prime at x. Okay, so the definition of this is f of g of x prime. Okay, now chain rule. Chain rule says that take the derivative of this and multiply it with the derivative of this. Of course, you evaluate them at the reasonable points, at wherever it makes sense. F prime evaluated, okay, so this is the point where you have to evaluate it, times the derivative of inside is g prime x. Okay, so this is the formula. Now let's see. We want to put x equals 0. Okay, so let's say this, put x equals 3. So you have f prime of g of 3 times g prime of 3. Okay, so g of 3 is 4. So this is f prime 4. G prime 3 is 6. Okay, f prime 4 is 16, 17. 17 times 6. Okay, so what is 17 times 6? 102. Okay, so that one is okay. Now I need the second derivative, f composite g double prime x. Okay, so this thing is equal to this. The first derivative is this. I want to take the derivative of this, f prime g of x times g prime x derivative. Okay. Now this is derivative of a product. So the derivative of this times this plus this times the derivative of this. So I'll apply this. Derivative of this thing I already know. Okay, so it is equal to this, f prime g of x times g prime x, and I'm multiplying it with g prime x, plus I have this, f prime g of x times the derivative of this. The derivative of this is second derivative. Okay, so instead of
derivative of the first one, f prime g of x, it's not the same as
the derivative of this, I put this one here. Okay, so now that's, okay, so the derivative of this, and the derivative of, okay, so I was wondering somewhere I need this one. Okay, so I can use it. Okay, now we do the same thing. Put x equals 4. Okay, so here put x equals 4. So f double prime g of 4, g prime 4 square, okay, 2 of these, plus f prime g of 4 times g double prime 4. Okay, so let's see. G of 4 is 5. G prime 4 is 8 square. So let me write 8 square so that if we need to check this, we know what we are, why we wrote 64 there. F prime, what was G of 4 was 5, right? F prime 5 times G double prime. G double prime 4 is 13. Okay, so one more here. F double prime 5 is 24. 24 times 64 plus F prime 5 is 26. 26 times 13. Okay, so you calculate this. Where do I get these things? For some reason I have different numbers here. So, okay, so what is this number? F prime 5 is 25, 26. G double prime 4, 12, 13. Okay, so why do I have these different numbers here? Yeah, the numbers. In my notes, I asked the second derivative at 4. In my solutions, I calculated at 7. Okay, you get 0. Okay, so this is the correct answer. You calculate this here. Did anyone calculate this? No? Well, Okay, in the exam you have, in real life you have to. In the exam you may get a full credit at this line, but in real life you need that number. Okay, so any questions on this?
Isn't an variable?
No, we said that the functions are such that at integers they get these numbers, but in between they can oscillate when x is...
Just this one.
Yeah, just for this problem we invented such a setup. But the function f of x is not 2x plus 1, okay? F of x is something different, but when x is an integer it takes this value. Okay, then it may go up and down, and in the next...
Only these three volumes.
Yes, only, and we evaluate only at these. You see here we evaluate them at integers. If I had 4.1 here, this information does not tell us anything. Okay, any questions? Okay, so we even did this one. So number 6. Okay, so since these are now interesting problems, do we have time? Well, okay, so let me, since we can't solve all of them. Okay, so let me go with my setup. Okay, problem 6 is, so this is compile of Eudoxus. Okay, so the equation is this. So the problem is, this is the equation is y squared is equal to 5x to the 4 minus x squared, or r squared is equal to 1 over square root 5 secant squared theta. Okay. Well, this is, write the equation, write an equation for the tangent line at 1, 2. Okay, so this is an exercise in implicit differentiation, because the curve is not given as y equals something, it is y squared. You can, in this example, you can solve it y equals square root of something, okay, and that will be your punishment because the derivative will be complicated. But if you use implicit differentiation, calculations will be easier. So that's why you use different methods to solve the same problem, same type of problem, because depending on how the problem shows up, one method is easier to apply. And sometimes the other methods don't even practically work there. Okay, so the graph of this thing is something like this. Okay, so it comes like this. It comes like this. Here makes a, and then goes like this. Well, it doesn't. I'll change it. It doesn't come to the origin. Okay, and then it has something like this. Okay, so it comes like this and goes like this, and somewhere in between is y-axis. Okay, so this is how the curve looks like, more or less. Okay. So for this kind of problem, first you have to check where this point is. If this point is outside the graph, then you have a totally different problem.
0, 2, 0. The points 0 and 0 is not correct.
Well, when x is equal to y equal to 0, yeah, they touch each other at 0. what happens with theta when theta is, okay, so either, maybe this is not correct. I wanted to give that as an extra information because this is where, I'll check this part, okay? So you see this doesn't pass through 0. Maybe we should add something to this. Okay, so in such problems, write the equation for the curve is given, a point is given. Write an equation of a tangent line passing through this point. If the point is not on the curve, you have a totally different problem. If the point is on the curve, then that's a simple problem. Here we check first that this point is on the curve or not. Okay, so solution first. Check if 1, 2 is on the curve. Okay, so put x equals 1, so you have 5 minus 1 equals 4. So this is equal to 2 square. The point is on the curve. Okay, so now we have a simple problem. We just find the slope of the curve at that point, and then we write the equation of the tangent line. Okay. Now we find y prime at 1, 2. Okay. We use implicit differentiation. Okay, so 2y prime is equal to 20x cubed minus 2x. Okay, put xy equals 1, 2. So what will you get? You get here 4y prime equals 20 minus 2, 18. So y prime is equal to 9 over 2, right? Okay, so equation is easy. Okay, so this, let us call this M. Okay, general equation for tangent line at x sub 0, y sub 0 is y equals m x minus x sub 0 plus y sub 0. In our case, y is equal to 9 over 2, x minus 1 plus 2. Okay, so this is the equation. You can simplify this. Or 2y minus 9x equals 5. Okay, so it looks better if you do it this way, if you are eventually going to use it. Okay? So the next one, okay, let me skip this one. This is again another curve. Again, y squared equals something, some other thing, of course. I'll skip that. Okay, let's do one show that problem, because I know you love show that problems. Or rather, let me change it into a form where you don't see the word show that, so that you won't be discouraged. Okay, so this is 7. Find the sum of the x and y intercepts of any tangent line to the curve square root of x plus square root of y equals square root of c. Okay, so here obviously c has to be something positive. Okay, so this is the curve. I didn't plot it. So I don't know what it looks like. Okay. So we'll take any point on the curve. We'll find its slope there. Using that slope, just like we did there, we'll write the equation of the tangent line. We'll put x equals 0 and find y, write it somewhere. We'll put y equals 0 and find x, write it there. We'll add them up. And if this is a nice cooked up example, we'll be surprised. Okay? So, again, this is an exercise in implicit differentiation because y is not explicitly given. You can attempt to solve for y by squaring these things, take one to the other side. You'll get a little bit complicated expressions. Okay? So doing this, you can also do that in this case because it won't be that complicated as in the other one. Okay? So I used implicit differentiation. Okay? So first, find y prime. Okay, so let's find y prime. The derivative of square root x is 1 over 2 square root x plus 1 over 2 square root y times y prime, chain rule. Okay, implicit differentiation together with chain rule equals derivative of c is 0. Okay, so here y prime is equal to minus square root y square over x square. Okay, when x square is different than 0. So at this point, at x sub 0, y sub 0 on the curve, when x sub 0 is different than 0. Okay, so this is the slope. So equation of tangent line. Y is equal to slope y square x minus x sub 0 plus y sub 0. Okay. Now we want to find x and y intercepts. Now next we want to find this. So put y equals 0 and solve this. When you solve this, you get, okay, you get, so let me call this x1, y-intercept. So after I solve this, I got square root x sub 0, square root y sub 0 plus square root x sub 0. Okay, so you just put y equals 0, solve for x, simplify it until you are satisfied, or don't simplify it at that point, just write what the x is, because at the end we'll add these two things. Maybe you want to simplify after that. Okay, so it all depends on your taste. Okay, so next put x equals 0, so let us call this y1. So when you simplify this, this is square root y0 square root x0 plus square root y0. Okay? So sum of these intercepts, x1 plus y1. Okay, what do you get? Okay, you add these two things. What is inside? What is the value of this on the curve? Somebody says, well, inside is square root c, so you add these things, then c. And I told you would be surprised. Okay, so no matter where you do this, Okay, so no matter where you do this, you'll get C. Well, we missed only one case when x sub 0 is 0. When x is 0, okay, so you have this, then you square this, you only have y-intercept then, and the sum of that when y is equal to c. So even in that case, the sum of the intercepts is 0, is c, no matter where you do this. Okay, so such funny things do happen. Do we have time? Well, we have time, so let me find one more thing. So which question we can squeeze into 5 minutes? Oh, this one. Okay, let's do this one. Since you enjoyed this one, let me find one that looks like it. Okay, so this is 8 before the last question before the quiz. Let us consider this function, x minus a, x minus b, x minus c, where a, b, c are distinct numbers. Okay. Find the x-intercept, or find the point where the tangent line to this curve at x equals, at the average of the roots, two roots, a and b, so a plus b over 2. Find the point where the tangent line to this curve at this point intersects x-axis. Okay? So we don't know the shape of this thing. The shape of this thing will depend on the values, but here is, suppose that this is what happens, a, b. And of course, these numbers don't go like this. Maybe c is here. I know that the function has a 0 here, it has a 0 here, and it has a 0 here. Okay, so at the middle point here, a plus b over 2. Okay, so, well, here it is. Here we draw, we don't have this. Here we draw the tangent line. And we want to find where it intersects. Okay, so let me make it at C. It will. We claim that it will intersect it always at the other 0, but I'm not claiming anything here. Okay, so let me erase this. So far, we don't know anything. Okay, so suppose we start from the beginning. Okay, so the problem is we take the derivative of this function, put x equals a plus b over 2. That will give us the slope. Write the equation of the tangent line, okay, and put y equals 0, solve for x, okay. So you will have huge equations here because since we don't know what a, b, c are, nothing cancels. But at the end, everything will cancel, and this is what we will get. Okay, so for the ease of notation, let alpha denote a plus b over 2, okay. F prime, this is calculus, so if you don't have any ideas, take the derivative and see what happens. Okay, the derivative of this is 1 times the others, x minus b, x minus c, plus x minus a, x minus c, plus x minus a, x minus b. Okay, so that's the general derivative. We are interested in this number. Okay, so alpha minus b, alpha minus c, plus alpha minus A, alpha minus C plus. Okay. So you will get some simplification here, because if you subtract A from this is going to be B minus A over 2. If you subtract B from this, you'll get what, A minus B over 2. But if you subtract C from this, you won't get something nice. You'll get A plus B plus 2C over minus 2C over 2. Okay. You'll simplify this, you'll get a number. Okay. So that's why you have to go to Wolfram alpha, write this, and it will simplify for this. Equation of tangent line at x equals alpha is y equals f prime alpha. I have this number. X minus alpha, alpha is this number, plus f of alpha. Okay, now you have to put alpha here. Again, you'll have a huge expression. So you don't want to do this yourself. So you give this equation to Wolfram alpha, say simplify, and it will give you a simple expression, which I did not do that part because it's complicated. Okay. Now put y equals 0 and solve for x. Okay. Okay, so when you solve for x, you will get, okay, so let's solve for x from here. So you see this is equal to 0. So x is equal to, this goes to the other side as minus f alpha. Then I'll divide it with this. Okay, and okay, so, okay, let's do this. I have f prime alpha x, and I have plus alpha times f prime alpha minus f of alpha. Okay, so I kept this here, and I send this to the other side, this to the other side. So x is equal to alpha minus f of alpha over f prime alpha. Okay, simplify, and you will get C. Okay, so you write this to, you don't do this by hand. Okay, so this is not supposed to be something you do by hand. That's why you have programs such as Wolfram alpha. You write it there. You hit the button before you take your hand off. You see C there. Okay, so that's the surprising thing about here. You see, there is not. You don't want to repeat this now if it will work with B and C, because here which A, B, C, we don't know what they are, except that they are zeros. We take the average of the two zeros, A and B. You can take any of them. At that point, we calculate the tangent line. The tangent line gives you, at the x-intercept, the other zero. Okay? So let's stop here so that we have 15 minutes for the quiz.